Hello everyone, I am Dr. Hydrological. I welcome you in my YouTube channel. Today in this video, I am going to talk about hydrological cycle. You know, hydrological cycle is very important in hydrosphere and play important role in hydrosphere. So let us start with the ocean storage. You know, Earth's water 3.5% and 96.5% oceans in Earth. Another means only 3.5%. So, what percentage of Earth's water is stored in the ocean? So, water source oceans and total global water volume you can see 66 and percentage of total water 96.5%. This is the survey. Now, does the volume of world oceans ever change? You know, last glacial periods sea level 400 feet lower than today. 400 feet. Think about it. 400 feet lower than today. So last interglacial period sea level 18 feet higher than today. So sea level 165 feet higher. So southern extents of glacial ice 20,000 years ago, you can see. Landward limit of coastline in the past 5 million years. See the situation. And current location of the coastline and locations of coastline 20,000 years ago. This is, you have to think about it. Now, what two process change liquids into vapor? Liquid water into vapor that can ascend into the atmosphere. So first, evaporations. This term is very important. Evaporation 90%. Transpirations 10%. What percentage of water in the atmosphere comes from? That is the important question. Evaporations. So what is evaporations? The process by which liquid water is transformed into a gaseous state. Evaporation into a gas ceases when the gas reaches saturation. The molecules that escape the condensed stage have above average energies. Those left behind have below average energy and manifested by a decrease in the temperature of the condensed phase. Now, evaporations. You know, my friends, evaporations energy breaks bonds that hold molecules together. Net evaporation occurs when the rate of evaporation exceeds the rate of condensation. Removes heat from the environment. So that is the net cooling. So primary mechanism for surface to atmosphere water transport. Now, evaporations, you can see the situations in this picture. This per day x-axis starting from minus 180 to 180 and this is minus 60 to 60. So most prevalent over ocean. Now evaporation versus precipitation. About equal on a global scale. Evaporation more prevalent over the ocean than precipitation. Over land, precipitation exceed evaporations. Most water evaporated from the ocean falls back into the ocean as precipitation. 10% of water evaporation from the ocean is transported over land and falls as precipitation. You know, once evaporated, a water molecule spends 10 days airborne. You know airborne? In premature form. Transpirations. The process of water loss from plants through stomata. You know the stomata? Stomata are a small opening found on the underside of leaves that are connected to vesicular plant tissue. Now, passive process that depends on humidity of the atmosphere, the moisture content of the soil. Only 1% of water transpired used for growth. So transports nutrients from the soil into the roots and carries them to the various cells of the plants. Now transpirations account for 10% of the moisture in the atmosphere. Depends on temperature, humidity, isolations, precipitation, soil type and situations, wind and land slope. So what percentage of Earth's total volume of water is stored in the atmosphere? So 0.001% water vapor, clouds, water vapor condense on particulate. So global distribution of atmospheric water. You can see the water source, volume in different, total global fresh water, total global water. So this is data. Now precipitation, the vapor that accumulates or freezes on condensations, nuclei is acted on by gravity and falls to the earth's surface. Rain, freezing rain, sleet, snow or hail. Primary connection in the water cycle that provide for the delivery of atmospheric water to the earth. So my friends, I hope you will understand this total precipitable water. So total atmospheric water vapor contained in a vertical column of unit cross the sedimentation area from the earth's surface to the top of the atmosphere. Height to which water would stand if completely condensed and collected in vessel of the same dimensions. So how many gallons of water fall when 1 inch of rain falls on 1 acre of land? So about 27,154 gallons of water. On average, the 48 continental United States received enough precipitation in 1 year to cover the land to a depth of 30 inch. So meteorological factor affecting the surface over soil, runoff, types of precipitation, rainfall intensity, rainfall amount, rainfall duration, distribution of rainfall over the drainage basin, directions of a storm movement, precipitation that occurred earlier and resulting soil moisture, meteorological conditions that affect the evaporations. Now physical characteristic affecting surface runoff. Land use, vegetation, soil type, drainage area, basin shape, elevations, topography, especially the slope of the land, drainage network pattern, ponds, lakes, reservoir, sink, etc. in the basin which prevent or delay runoff from continuing downstream. You can see overland runoff from disturbed area often contains excessive sediment in addition to water. So human factors affecting surface runoff. Urbanizations, more impervious surfaces reduce infiltrations and accelerate water motions. Removal of vegetations in soil surface, grading, artificial drainage network, increases volume of runoff and shorten runoff time to stem from rainfall and snowmelt. So most runoff drain to a creek, to a stream, to a river, to an ocean. rarely runoff drain to a closed lake, may be diverted for human uses. So stream flow makes up a minuscule amount of earth water. So this is the table. Water source, stream flow, total global fresh water, total global water. Now lakes and swamps. Fresh water makes up 3% of all water on earth, and lakes and swamps account for a mere 0.229% of that. 20% of all fresh water is in the lake Baikal in Siberia, and another 20% is in the Great Lakes. Now groundwater begins as infiltration. So precipitation falls and infiltrate into the subsurface soil and rock. So can remains in shallow soil layer, might seep into a stream bank, may inflate deeper, recharging an aquifer, and may travel long distances, may stay in a storage as groundwater. So factor affecting infiltrations. Precipitation. Greatest factor, magnitude, intensity, durations, characteristic, rain and snow. The second important point, soil characteristic. Clay absorbs less water at a slower rate than sand. Soil saturations. Higher saturation leads to more runoff instead. Land cover, slope of the land, hills enhances the runoff velocity. Evaporations, plants use soil moisture to grow and transpire. Now, infiltrations, replenished aquifer, water table, unconfined aquifer, unsaturated zone, water tables, stream, confined aquifer. So slow process, groundwater moves slowly through the unsaturated zone. Recharge rate determined by the precipitation and depth. An aquifer in New Mexico, if emptied, would take century to refill, whereas a shallow aquifer in South Georgia may be replenished almost immediately. So subsurface water, you can see here, soil zone, water table, recharge to water table, precipitations, capillary fringe, saturated zones below the water table, groundwater. So as precipitation, infiltration, subsurface soil, it forms zones. Unsaturated interstitial space cannot be pumped. Saturated water completely fills the voids. Now natural and artificial recharge. You can see storm clouds, precipitation, natural recharge from precipitation, runoff, sand and marbles, artificial recharge well, pipe to source of recharge water, control valve, soil, steam, natural recharge from steam, groundwater reservoir. So rapid infiltration pits. Spread water over the land in pits, furrows, ditches, or build a small dam in creek and stream to deflect runoff. Groundwater injections, construct recharge wells and inject water directly into aquifers. So how much groundwater? Groundwater occurs only close to the surface, a few miles down. Density of soils per rock increase with depth. The weight of the rock above condenses the rock below, squeeze out the open pore spaces deeper in earth. So earth water, total fresh water 1.7% and 30.1%. So earth groundwater, fresh water and saline. Now frozen fresh water stored in glacier, ice field and snow field. Glacial ice covers 11% of all land, represent a large percentage of all fresh water. Mountain snowfield are reservoir for many water supply system. 75% in western state. Rain onslaught event contribute to high runoff velocities and new operational snow melt forecasts. So you can see the earth water total fresh water 1.7%, 68.7%, ice cap and glacier. How much of all fresh water? So my friends, you can see distribution of earth water. Fresh water 3%, other 0.9% and river 2%. Look at here this graphical presentation. So this is the most important. Precipitations, leaf on tree, evaporate clouds, patches of dry dirt in flat field. Read it this one. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel and thanks for watching.